So Steve, we are now trying to put your face in the big screen here.
Okay.
Here it goes.
All right. Very nice.
Just a while, just a minute. So in the camera, you can see me, of course, and Professor Carlos Borrego, who is chairing this session. Hello, Steve. All the audience is looking at you, although you don't see anyone right now, but you will see in a couple of minutes. Professor Borrego will chair this session, and he will say a few words before we give you the floor, okay? Thank you for coming.
Okay,
Thank you for being up so late. So early.
Yeah.
Hello, good morning. It's a pleasure to welcome all of you and to start this keynote speak. Is the first keynote speaker this morning in the conference. I would like also to tell you that we will have some presentation and at the end, some questions can arise. Well, I'm Carlos Borrego from University of Aveiro, Department of Environment and Planning. And I would like to thank to Xavier Viegas, which was my colleague during the mechanical engineering course. We both together did this course, and to thank for this invitation. Well, I see that Stefan Pine is already ready to start, and he is emeritus professor at the Arizona State University, United States, and Regents Professor in the School of Life Science at Arizona State University as well. He is author of over 30 books, mostly on the history and management of wildland and rural fire, including big screen surveys in US, Canada, Australia, Europe, and around the world. He is completing a multi-volume fire history of the US and the regions and its regions from 1960. Steve is a fellow of the American Society for the Advancement of Science and has received numerous awards, and the most recent being recognition of special service for long-term instruction by the National Advanced Fire and Resource Institute in 2016. With his books and publications, Stefan gave us a reference frame to place fire in the history of humanity and of the world in its various dimensions. He says that he participates in Earth transition from a world informed by ice to a world informed by fire. The book, Pyrocene Park, will be published in May 2023. Let's see what Stefan has to tell us. It's your floor, Stefan, please.
Well, good morning, and thank you for this great honor to be able to present a keynote talk to what promises to be a stellar conference, and I deeply regret I am unable to attend in person. But let me suggest to a group that needs no introduction to fire a different way to frame some of the issues that are before us today, or what I call the Pyrocene, which is a story of how humanity has created a fire age. Well, fire has been on the planet as long as plants have been on continents. Lightning was an effective means of ignition. But then a creature arrived, a genus, now just a single species, who was able to manipulate fire in special ways. We got small guts and big heads because we learned to cook food. And then we went to the top of the food chain because we learned to cook landscapes. And now we've become a geologic force because we've begun to cook the planet. We are the keystone species for fire on Earth. In effect, a species monopolist. And what happens on Earth is intimately connected with us. Long time ago, our ancestors made a pact with fire, a mutual assistance arrangement, although in recent years, it's beginning to look more like a Faustian bargain. Let me present my concepts using the United States as an example, and I love this map from 1880. These are forest fires in the United States. This is our pyrogeography. It does not include, by definition, grasslands, deserts, and so forth. And this is a result of three kinds of fires that have acted historically. The first, of course, is lightning, natural fire, what we might call, and this is the map of what lightning ignited fires in the US would look like, a very different map. Some points of overlay, but fundamentally different. Part of what first nature might have looked like if lightning alone were in operation. But we know that that's not the case, and the map behind us shows really the operation of humans, those who were indigenous before European contact, and the newcomers and their understanding of fire and their practices. And in effect, they have made, in the US as around the world, what Cicero in ancient Roman times called a second nature, working with the natural world to restructure and reorganize it. And fire was a fundamental means of doing that. And we can see this clearly. This is a map below of population density in the US and above of fires. But there's a third fire, what we might call industrial combustion, or the burning of fossil fuels, signified here by a train crossing the continent. And that is creating, in effect, a third nature, different in character and dynamics, and with its own curious arrangement of fires. So all of these early fires, first and second nature fires, occurred in living landscapes, which meant that they came with checks and balances, ecological baffles and barriers that meant that fire could occur in certain places and times and not in others. And this was flexible, but it still had important borders applied to it. When, however, we go to a third fire environment, we begin burning what I like to call lithic landscapes, once living, but now fossilized landscapes. And this provides an almost unbounded source of fuels. Humanity's quest for fire had been one to search for more things to burn and more ways to burn it. But now the problem is becoming where to put all of the byproducts of that burning, because it exists outside the checks and balances, the arrangements that had existed in living landscapes. We can burn day and night, winter and summer, wet or dry, it doesn't matter. And we begin applying this new firepower to all of our habitats, beginning with domestic settings in houses, used to be filled with working flames for heating, lighting, cooking. Now, converted to non-flammable, or open flames have disappeared. Our cities used to burn as often as the surrounding countryside. Well, they were made typically of the same materials, and so they burned under the same conditions. But now they're designed not to burn. In effect, all the materials that go into making buildings like these have been burned previously, and now are relatively immune to fire. And we extend this into our fields. Agriculture, a primary way we have remade raw nature into second nature. We now have applied from lithic landscapes, petrochemicals, fertilizers, pesticides, herbicides, applied by machines and often irrigated by pumps and so forth that also require combustion as a primary source of energy. In effect, the Green Revolution was not just about new breeds or varieties of wheat and rice and so forth, but of the inputs that they could accommodate. And this has remade many agricultural landscapes, eliminating, for example, the practice of fallowing, which is where most of the biodiversity in agricultural landscapes reside. And then, perhaps improbably, we have extended that same new firepower into our broader rural landscapes and outright wildlands. Previously, we had lived in these fires by changing the landscape in favorable ways and applying our own fires to replace those of accident or arson or nature. And now we apply that same kind of industrial firepower to controlling fire. And this gave rise in the 19th century throughout the European colonial world to a great havoc of wildfires, megafires in many ways larger and more lethal than what we've seen in in recent decades. And this gave rise to state-sponsored conservation as a response, and a core practice of that would be fire control. In the United States, our first professional forester from Prussia, Bernard Furneaux, dismissed the American scene as one of bad habits and loose morals. From Central Europe, he saw fire as strictly a human problem and an index of social order and behavior. Our first American forester, Gifford Pinchot, likened the fight against fire to that against slavery, and argued for an abolitionist position. And then through a series of acts, we created an institution, a primary institution that would be responsible for managing fire on our protected forests and then beyond. This transition to sort of industrial combustion, I like to call the Pyrrhic transition. That's been a problematic term. I'm going to use it, but we can discuss later its quirks. But here's a chronology of primary energy. And you can see even today how much of it is dominated by combustion. This, of course, is a major concern to us now. But let me pull out of that an era for which we have statistics of burned area in the United States. And you can see that as third fire increases, first and second fire shrink. The ability to move unprotected areas into protected status is very effective. That in effect, as our living landscapes reduce burning and our lithic landscapes increase it. Here's another graph showing the burned area, in this case measured against fossil fuel emissions, again for the United States. And we can identify, or I would like to identify, a kind of sweet spot where the transitional period is very effective at removing open flame and a large amount of smoke, and in effect replacing it with the products and power provided by industrial combustion. We improve our fire suppression, again, by appealing to this new firepower, and we are able to improve, we might call fire exclusion. People are no longer setting fires the way they used to. The landscapes are changing because they are coming into accommodation with this, what I would like to call a third nature, and that is a nature for which fire is removed. Unfortunately, after this area, we begin to see the consequences, a kind of ecological and even climatic blowback. But for this period of time, was influential in suggesting that this strategy could work in wildlands. And just imagine what kind of fire suppression, firefighting would be possible if we took away our helicopters and airplanes, our engines and bulldozers and water tanks, our chainsaws and pumps. Almost nothing that we could presume. We would have to do what humanity had always done previously. That is, to manage the landscape, to make it more amenable to fire of our sort, and then to put our fires in place of wildfires. So in the United States, beginning with roughly 1910, the great fires of that era, which galvanized a response, an institutional response. We spent 50 years trying to take all fire out. And then in the 1960s and 70s, recognizing the problems this caused, we reformed policy at the federal agency and have spent 50 years trying to put good fire back in. And I would point out that all of this happened before climate change was a serious consideration. In fact, climatologists at the time were telling us we were headed for a new ice age, and that changed. And now I think we are beyond this revolution, looking at a world which needs to be defined in somewhat different terms. So let me return to this lovely lithograph of a locomotive, literal engine of industrialization crossing the continent. One of the interesting features is that there is fire on one side and no fire on the other. And that, in a sense, is what this transition brings to particular landscapes. And we can see some extreme examples of this. This is near in southern Arizona, Biosphere 2, a completely designed, self-contained world, something that could, in principle, be plopped onto Mars, and it has absolutely no place for fire. While in the background, in the actual living world, we have fire as both essential and inevitable in a protected forest area. But this division is quite pronounced. We can see it in evening satellite photos of Europe. Not all of those lights are powered by industrial combustion, of course, but the society, even in the areas that rely on nuclear or hydro, are still fundamentally fossil fuel societies, where in sub-Saharan Africa, we can see it's still traditional burning in living landscapes dominates, except where there are developed cities that have industrialized. And this is partly, I think, an explanation for why megafires are a pathology of the developed world. Why is it that those areas that have the highest density of science, the greatest industrial might, the most firefighting capabilities, and so forth, why are they the ones that are being hit by damaging megafires? We can see some extreme examples. The two Koreas, South Korea has made the transition, North Korea has not. Conspicuous by the absence of evening light. But if you look at MODIS imagery, you can find that nearly all the hotspots are contained exactly within the political entity we call North Korea. And having made the transition, South Korea is now beginning to experience the kind of fires associated with it. And earlier this year, large wildfires required the mobilization of all-out firefighting, including helicopters like this, and mobilization of the military. So a photo I like, this is from Alaska, the Alaska pipeline bringing oil, and to the side, large wildland fires. This is a map of hotspots of fires for the United States, produced from NASA imagery. But let's compare that with the CO2 emissions. And if you go to finer grained, the closer you work this comparison, the more you realize that you have one or the other at a particular place. And this transition tends to remove, as I say, working fires, open fires. And we're beginning to see ways in which these two realms collide, of which power lines are a great example. Some of our most disastrous megafires, particularly in California, but elsewhere, have been the result of power lines creating spark in these altered landscapes. So megafires have now joined, but we should also note that it is not strictly tied to particular places. It's not a local phenomenon, because the effluent of our burning has gone to the atmosphere, is changing climate. And so we have competing fires at a local level, but we have fires colluding at a global level, and now worsening, aggravating existing fire scenes, so that megafires have joined polar bears as an emblem of an Anthropocene run amok, or what I would like to call a Pyrocene. And indeed, ancient prophecies, it seems, are becoming present realities. Part of my interest in trying to rethink the fire scene is that I've been struck by those who regard that our future is so not just dire, but strange, that we have no narrative by which to connect it to the past. And we have no analog by which to understand this future. We are living in a no analog world. I disagree. I think we have a fabulous narrative. It's the story of humanity and fire, unbroken. And we have, I think, a good analog, which I'm about to elaborate. And I would point out that climate history is, in fact, now becoming a sub-narrative of fire history. It is humanity's ability to burn things, to find new ways to burn it, that is driving our problem. Well, as the saying goes, all models, and I would add all metaphors, fail, but some are useful. And here is mine. The Pleistocene, the last 2.6 million years, was dominated by ice, serial ice ages, huge ice-informed landscapes, also periglacial landscapes, lakes, permafrost, and so forth, drop in sea level, mass extinctions. These are critical parameters of the ice ages. And the hominids, we are coextensive with the Pleistocene. And here we have imagined erectines doing what hominids do, bringing fuel to the fire. But let's pass that world through a Pyrrhic looking glass. And what we have is something called a Pyrocene, driven not by Milankovitch cycles, but by anthropogenic burning. And we have fire-informed biotas, not necessarily burning day and night constantly, although if we consider industrial combustion, there's that, but everywhere reshaping biogeography and driving off ice. Our firepower is putting ice to its very limits. But all these peripheral or collateral landscapes we have that are emerging, changes in sea level, mass extinctions. And among these peripherals, we could consider the modern equivalent of outwash plains might be debris flows. And instead of proglacial lakes and pluvials, how about smoke palls and heat domes? All of these are sort of informed by fire. Instead of growing permafrost, we're removing it. Instead of encouraging forests and kinds of biotas that have been around for thousands of years, we are overturning them. And many are unlikely to recover. And in fact, outright desertification is possible. And what about our hominids? Here they are not bringing fuel to the fire, but using their new fuels to flee from fires. This is in Alberta, Fort McMurray fire. Fort McMurray, a town created to mine tar sands, particularly dirty fossil fuel, hence a modern city plucked down in the boreal forest. And now the two realms of fire are competing, are colluding in this case, and people are using their new power to flee from their old. So we are going, I think, from a fire crisis to a fire epoch, or what I have called the Pyrocene. It's no longer about learning to live with fire. I think the challenge is how to live with a fire age. The fires that we are seeing, particularly in the developed world, are the fires that are peculiar to the kinds of landscapes and indeed the kind of atmosphere and climate that have been created by fossil fuel civilizations. And so it is not just about climate change, and it's not just about land use or land management. In a sense, both in the developed world, at least, are being underwritten by this transition. which I would point out is a fire story. It is a continuous narrative of humanity and fire. When we make this transition, we put the whole process on afterburners, but we have been doing it for a long time. And fire is integrating all of this. Fire takes its character from its context. It synthesizes its setting. And what we are getting are the kinds of fires peculiar to how we live on the land and affect how humans inhabit the earth. So there are three challenges. A fire community likes fire triangles. Here's one for the Pyrocene. We need to protect our communities. In many cases, this is, I believe, is a problem of misdefinition. We thought of these as wildland fire problems that impact communities. It's better to think of these settings as urban fires, urban settings with peculiar landscaping. This is Paradise, California, a famous town obliterated essentially by a fire in California. And note that the buildings are incinerated, the cars melted, but the trees came through pretty well. So this is not really a wildland fire problem. Although the wildlands may be a source of the ignition, it is really a problem of not building cities to accept fire. We thought that that had gone away. We didn't need to practice pyric hygiene anymore. And for me, as a historian, this is like watching polio return. We thought we had fixed it, and then we thought we didn't need to take measures anymore. And we also need to get our landscapes, our rural landscapes, our wildland landscapes back in better form, more resilient to fire. This will require a variety of techniques, of which restoring fire on our own terms, the right kind of fire will be essential. They will burn. They can burn under the worst possible conditions with massive changes or incrementally. And we need to do this as, again, a kind of mitigation while we take care of the climate issue. This is a great photo. I love this. It's a Hazelwood power plant. It was in Australia. It was built to next door to an open pit coal mine. And many of the deaths in the Black Saturday fires in 2009 were the result of fires started by power lines from this plant. And then subsequently, the open pit coal mine caught fire from a bushfire. And so we have this completed realm of positive feedback. And now the plant has been has been shut down. But put all these together and we have the realization, and perhaps this group doesn't need to be reminded, that fire and fires management is systemic. We have thought of it for too long as something that happens seasonally, something that is an emergency response, something that can be done incidentally or part-time to a more primary assignment. Fire management is fundamental to all of these realms. Fire management on the whole is what is informing the world today and will continue to inform our future. And we have a lot more fire in our future. As we ratchet down our burning of fossil fuels, we will be ratcheting up our burning and living landscapes. We have a huge fire deficit in many areas, and areas that we have not been burning for a while will need to in some form. So I go back to the Pleistocene, our ice ages, and the graph below showing CO2 levels. You can see those blue stripes, these interglacials. About 80% of the Pleistocene was glacial, about 90% of the last million years. And it's broken by these short periods of rapid warming and then long, steady cooling. And we have been in one. The Holocene is one of these interglacials. And we're about ready to enter the ice again, except that we've intervened. We intervened at such a large scale that instead of an ice age, we are creating a runaway fire age. But it may mean, nothing has changed in the rhythms, the Milankovitch rhythms, the arrangement of continents and oceans and so forth that were underwriting these old ice ages What we have changed is the atmosphere. And it may be that we will need to burn in the future at large scale to prevent the ice. Faced with a future of ice or fire, I would take fire any day. We are a fire creature. We need to manage it better, but we will very likely be using fire in the future, perhaps the not too distant future, perhaps the future of 1,000 or several thousand years from now. We will need fire to protect us from the ice. So again, in one form or another, we have a lot of fire in our future. So what does that future look like? Well, that really depends on us. The Old Testament prophet Ezekiel declaimed that they shall go out from one fire and another fire shall devour them. And that does seem like our current and longstanding situation. But actually, our current situation is different and trickier, because we are not passing between two fires. We are having to navigate between three. And like any three-body problem, it has no exact solution. But I remind us that fire is what we do. It's what we do that no other creature does. This is our ecological identity. This is who we are. And we should be up to the challenge. Good fire has made us, and bad fire may unmake us, but that choice is ours. And with that, I will thank again the organizers for the opportunity to speak now.
Thank you, Steve, for this nice presentation and the ideas about what will be our future. We have some time for a few questions. Please raise your hand and the mic will arrive.
Good morning or good night to Arizona. This is Kirsten Tonicke from the Potsdam Institute for Climate Impact Research. Thank you very much for this very inspiring and important keynote. I could ask a lot of questions, of course, because it was so inspiring, but maybe one key one towards the end. I like very much the summary or integration of industrial fire, i.e. our fossil fuel emissions, and the change of landscape fires or how we fight fires to complete exclusion. This is somehow giving the Northern Hemisphere perspective more or less, while in the tropics we know fire regimes go on. So would you expect when we're all aiming at reducing fossil fuel emissions to make sure we get somehow near the climate target of the Paris Accord, would you expect some lagged effects that mega fires would go on for quite some time because introducing fire back to a changed landscape would trigger some of delays that will dominate the 21st century in terms of changing fire regimes because the system has been disturbed so much? Thank you.
No, that's a great question. I have taken a Northern Hemisphere perspective, and especially the United States, because I had better documentation for it. An interesting paradox, again, is suppose, I think if I go back to our triangle of the Pyrocene, we could fix the threat to communities. And I might add biological reserves like sequoia forests and so forth. We could fix that in a handful of years if we chose. We understand what the problem is. It is simply a case of mustering the resources and will to do it. Our landscapes will take several decades, at least. And I suspect stabilizing the climate regime will take probably a couple of centuries. And I would also note that if we were to convert wholly to renewables, non-combustible sources of power, but we continue to use that power to shape the landscape in the same way we have, we will continue to have the same landscape fire problems. They may not be exacerbated by climate change, but we will still have all of these problems. So fire problems aren't going away once climate change is stabilized. And this transitional period, as you point out, is going to be very difficult. How are we going to manage dealing with this? Interesting development in the Western United States on public lands is to put all of your fire, when one of these fires emerges that could threaten communities or municipal watersheds or sequoia groves, to put your firefighting resources directly on those points, those places where the asset is threatened, but otherwise to back off some distance to a natural fire barrier and then systematically burn out. And so these burnout operations, if you do them properly, could be regarded as prescribed fires done under urgent conditions. And these can be quite large. And in the Western United States, prescribed burning as a kind of set piece has not worked. We have not been able to do this at scale. But managing wildfires, which in some ways I understand administrators hate because it's a kind of mashup. What are you doing? It's half suppression, it's half prescribed burning. We would like clarity. This is more awkward, but this is the way of getting a good fraction of good fire back on the ground. It is a case of working with the kinds of fires we will continue to experience and try to use that as best we can so that we have something when we do tame the climate and get that into manageable shape, we have something to work with. Otherwise, the fires may remake our landscapes to such an extent that it will be very difficult to recover. I'm sorry, that's a long-winded answer. Perhaps somebody else has a question.
Okay, thank you. Another question, please. We have a few minutes. Yes, please.
Hi, Stevie. It was nice to hear from you. We haven't met since you were in Brazil, in Paraná, many years ago. Just some questions about climate and about fire. Wouldn't it be proper to say climate variation rather than climate change? Because climate is not, it's always dynamic and it has always very varied and not changed, at least at my point of view. Many of the most destructive fires occurred much before people started talking about climate change, like the Pestic fire in the United States in 1871, and the Paraná fire in Brazil that burned 2 million hectares and killed 110 people in 1963, and the Ashe Wednesday fire in Australia in 1968 that burned a large area and killed more than 70 people. And nobody was talking about climate change. And remember that when the Greenland was colonized by the Vikings in the year 900, the Greenland was green and there was agriculture in that area. And now again, there is agriculture in the Greenland. So the climate varies from period to period, but at least to my point of view, it doesn't change. And this kind of climate change it's more political and economical issue. That's it.
Sure. No, I think you're correct. We don't have, I haven't found a good neutral term to describe it. Writing for journals, they will often insist that we use climate crisis or climate emergency rather than climate change. The climate is always changing, but I think we have clearly interrupted the cycle of changes. and exacerbated it, and it will be manifest at local areas. And you are correct that fires like Peshtigo, which started a 50-year cycle of megafires in the United States, extremely wide-ranging, was the result of land use change. But the land use change was being organized by railroads, which opened up new areas for land clearing and logging, and also distributed lots of sparks. And so this cycle of fires continued until it had ultimately exhausted itself. So to my mind, these large fires were the result of our conversion to fossil fuels as a source of energy, which changed the network of markets. In the American Southwest, a semi-arid climate, the result of railroads was to eliminate fire, because it was possible now to move large herds of cattle and flocks of sheep from that region to markets, which was not possible before. And so this sudden plague of sheep and cattle basically stripped the grass away. This is before foresters arrived and we began state-sponsored conservation. But it is a result of the industrializing process, which to my peculiar perspective is also dependent on fire, because fire was the source of power to connect those markets, which then rearranged the landscapes. And all this happened, as I say, we made major policy changes in the United States 50, 60 years ago. It was not driven by climate concerns, but it was driven by a conversion to a fossil fuel society and the kinds of land use we desired, and the capacity we believed we had to suppress fires we didn't want.
Okay, we have time for a question, but a quick question. Well, if there are no quick questions, a little more.
Well, let me then thank everybody again, particularly the organizers, Luis and Domingos, for the invitation. And I regret, especially looking over the audience, that I cannot be there in person to interact and to learn. It's remarkable how much fire has changed. 50 years ago, it was sequestered in forestry, a small group. It was done part-time. It was not seen as shaping the planet, and now not exactly a mega fire of research, but it has certainly swelled in ways that are quite astonishing, and all this even in my lifetime. So again, thank you very much, and I appreciate your patience.
Thank you again.